Okay, on page 43 of your packet, I want to go over a few vocabulary words for this Module 3. First word we're going to have is function notation. It's important that you know how to read function notation and you understand what it means. So basically, let's start with this function notation f of x. This f of x represents the y value for the graph that's labeled f at a point, any point on the graph that we'd represent with the letter x. So f of x represents a y value for a graph labeled f at any point x. So inside the parentheses is the point. Some examples of this. Let's say we had h of 4 equals negative 10. Let's make sure we understand what that means. So on this would be, the graph name would be h. The 4 represents the x value. The negative 10 represents the y value. So this is basically saying on graph h, when x is equal to 4, the y value equals negative 10. Together, that gives us a point on the graph. So this gives us a point on graph h, and the point is 4, negative 10. This is a regular ordered pair. Okay, so that's the basic thing you need to know about function notation. Another way that we use function notation is to evaluate equations. So let's say h of x was equal to 2x minus 18. Let's say you were given that. So the graph is the linear, is a line with the formula 2x minus 18. And if you were asked to find h of 4, basically what you do is you plug in 4 where the x value is. So we would evaluate that by doing 2 times 4 minus 18. And then 2 times 4 is 8, minus 18. 8 minus 18 is negative 10. So this is another way to see that the point 4, negative 10 is on the graph. When x equals 4, y equals negative 10. Alright, the next vocabulary word is intersection. We've talked about finding the intersection of two graphs. So the intersection in words is the place where two graphs cross. So it's the place or point where two graphs, actually it could be more than two, but usually we're comparing two, where two graphs cross each other or intersect. And when we're talking about the place, we usually, at a minimum, want to report the x value. Sometimes you can report the entire point, ordered pair, but at least the x value. So we'll take an example here. Let's say we have a line that's labeled as g of x, and we have a curve on our graph that's labeled f of x, and they intersect, and you can actually visually see right here is the intersection point. So you can find it here on the figure this way pretty easily, and you could just, if you were having to determine where the intersection point was, just find out, where the x-axis is. Go find out what the x value is on the x-axis. You could even find the y value on the y-axis. Some graphs you're going to be able to tell the intersection point just by looking at it. Analytically, you can find the intersection point by setting the two functions equal to each other. Okay, so as an example, we would take whatever the equation is for f of x, we would set it equal to the equation for g of x, and solve for x algebraically. The problem's on page 39 in your packet. That's a whole page of solving for an intersection point analytically. So you can try that page as an example on that page, and then you can check the answers with the answer key on Canvas. Okay, a couple more definitions here. Move the page up. Alright, the next word that we're going to cover is, it's not really a vocabulary word, it's a technique, adding functions together. When you're adding functions together, actually let's draw a picture first. Let's say I wanted to add this function, g of x, and add it to this function, h of x. When we're adding functions together, you basically want to add the y values. Okay? Adding functions, we add the y values for each x value in the domain. And probably what you noticed on the ones we've done so far is we just pick a few x values to add and then get a pattern to it, and then you can draw a line or draw a curve through those points you've created. But you have to remember that it's the y values that we're adding. Okay, so for example, let's say this was our, let's say this is 1, 2, 3, 4. So when x equals 2, we have those y values, we would add those. When x equals 1, we have these two y values, we would add those. When x equals 3, I tried to put that right at that intersection, we'd have, those are two separate y values right there. It's in point of intersection, so they're exactly the same. And then when x equals 4, we would have those two. So basically you would take each of these y values, so add the y values for these. And so you could do these points individually. Basically if you added these together, it would be another line. I don't have room to do it, but it would be another line coming across here. So you could do that point by point and see where you would be. Or alternatively, if you have the equations for these, you can add the equations themselves. And this is what we did for the pool problem with Allie and Dane's pools being drained. We added those equations together. So add the equations, say in this case g of x plus h of x, combine like terms. You could go back and look at the task for 3.5 to get an example of that. And then in the homework pages, the homework examples in 3.5, the 3.5 set had a lot of that going on as well for examples. The next vocabulary, or the next thing I want to make sure that you understand, is comparing functions. A lot of times you're going to be asked to compare function values. So comparing functions basically just wants you to look at where are the y values, or compare the y values of two functions to decide which one's bigger which one's smaller or where they were equal. So we're going to compare y values. You have to keep in mind that we're always comparing y values. So compare y values, and then the results of this, if you're talking about an interval where one function is bigger than the other, you're going to talk about the x values for the answer, but you actually have to compare the y values to determine what intervals have what feature. So, for example, let's say we have two functions, g of x and f of x, and we want to see where g of x is greater than f of x. So what we're going to look at is, look at the y values on g, and we want to see when they are bigger than the y values on f. And everywhere that the y values on g are bigger than the y values on f is where g of x is greater than f of x. And you would report this as an interval of x values. And there's a couple of examples of these in the first part of 3.6, the first couple pages. There were some problems that asked where is one function bigger than the other, or where is one function smaller than the other. Okay? Alright, please do the rest of the 3.6 pages at this point. You can look on Canvas for an answer key to check your work after you have tried it yourself. Have a good day.